Picture the end of the 19th century. That's when two self-taught American mechanics, brothers Wilbur and Orville Wright, became obsessed with the idea of human flight and started studying aviation. Technology was advancing fast, and the world was visibly changing. Yet actually pulling off the dream of building a flying machine still seemed impossibly far off. The early attempts were outright failures. Tests of early steam-powered aircraft, built by pioneers like Clement Ader in France, Hiram Maxim in Great Britain, and others, all ended in disaster. Experiments by the first brave glider pilots often ended tragically. In 1896, in Germany, the brilliant engineer Otto Lilienthal was killed during a flight on his own homemade hang glider. Just 3 years later, the same thing happened to Percy Pilcher, a British glider enthusiast who'd followed in his footsteps. One of the few daring souls who didn't give up and kept experimenting with gliders at the end of the 19th century was American engineer Octave Chanute. He significantly improved the basic design of Otto Lilienthal's hang gliders, making them safer and more practical. Still, most aviation enthusiasts of the time chose a different path and focused all their efforts on lighter-than-air craft, like airships and balloons. But real progress happens because you can't keep a good idea down, no matter how many setbacks it faces. Paradoxically, it was Otto Lilienthal's tragic death, or more precisely, the sensational newspaper articles about it, that sparked the Wright brothers' passion for aviation. That spark eventually led to the world's first successful powered airplane, but only after years of grueling work. In the beginning, Wilbur and Orville Wright were ordinary guys from Dayton, Ohio, not exactly the aviation capital of the world. They ran a small bicycle repair shop. In the evenings, the brothers devoured every book and article on flight they could get their hands on. Then they'd sit for hours, debating what their ideal flying machine should look like, and, most importantly, how to avoid the fatal mistakes of their predecessors. Finally, in 1900, the Wright brothers moved from theory to practice and threw themselves into designing their own flying machines. At that early stage, their ambitions were fairly modest. They weren't even thinking about powered airplanes and only dreamed of getting a glider to fly properly. For their future glider's wing shape, the brothers decided to copy the successful American biplane glider designed by engineer Octave Chanute. But that's where the similarities ended. The Wright brothers' design was truly innovative. Their glider had no tail section at all. Also, the pilot no longer dangled underneath, but lay flat on the lower wing. But the most important breakthrough was a fundamentally different, revolutionary method of flight control. Addressing the Western Society of Engineers in Chicago in 1901, Wilbur Wright laid out their reasoning simply and logically. He explained that after much deliberation, they'd concluded the conventional tail assembly caused more problems than it solved during flight, so they decided to eliminate it entirely. It also made logical sense that if the pilot were positioned horizontally, rather than hanging vertically as on the machines of Lilienthal, Pilcher, and Chanute, the aerodynamic drag could be significantly reduced. The old control method, Wilbur continued, where the pilot balanced by simply shifting his body from side to side, struck them as extremely ineffective and dangerous. So after lengthy debates, they developed a new system. They took two large wings, like on Chanute's successful glider, and added a smaller surface several feet in front. It was angled so that the oncoming airflow would automatically smooth out dangerous pressure shifts on the main wings. Thanks to this design, sudden gusts couldn't knock the craft off balance anymore. All the pilot had to do was calmly control the machine by gently angling this front surface up or down. But the single most important innovation, one that, strangely enough, Wilbur didn't even mention in his talk, was the control system. They controlled the glider's side-to-side movement through what's called wing warping. It worked like this. If one edge of the wing rose slightly higher as it met the air, while the other dropped, it created a force that allowed the pilot to level the glider and maneuver smoothly in flight. This was the direct ancestor of modern ailerons. The Wright brothers simply borrowed this brilliant control method from nature itself through long observation of birds. In his journal, Wilbur described how watching buzzards had convinced him of something crucial. When a sudden gust disrupted their balance, they restored it instantly by twisting the tips of their wings. If the trailing edge of one wing curled up while the other curled down, the bird would basically roll, pivoting around its lengthwise axis from nose to tail. Before risking this method on an actual glider, the brothers cautiously tested it on a simple kite. To their delight, the wing warping system worked flawlessly. Inspired by this success, in the summer of 1900, the Wright brothers built their first full-scale glider. This craft had a wingspan of about 17 feet and weighed only 52 pounds. The main building material, as with all subsequent Wright brothers creations, was ordinary spruce, with the covering made of sturdy fabric. The wing had a distinctive profile. It was sharply curved at the front and remained almost flat at the back. The designers genuinely believed this clever profile would help better stabilize the craft in flight. The wing's curvature was modest, a camber of about 1 in 22, meaning it was almost flat with just a slight arch. The long-awaited tests of this glider took place in the fall of 1900 in the remote town of Kittyhawk, right on the Atlantic coast. The location was no accident. The soft sand, cushioned hard landings, and the strong, steady winds created ideal testing conditions. The original plan was to launch the craft with a pilot on board using sturdy ropes, just like a large kite. With this cautious approach, the Wright brothers hoped to gain valuable flying experience without putting their lives at unnecessary risk. But things didn't go as planned. It turned out the wing's lift was far weaker than their calculations predicted. Even the strong ocean wind simply wasn't enough to get the craft airborne with a grown man aboard. So they had to test the glider mostly without a pilot, controlling it from the ground. Short flights with a person on board were only possible during gentle descents from sandy hills. This meant running straight into the wind to pick up speed. Since the pilot had to lie face down on the wing during flight, he couldn't exactly sprint down the hill to build up speed. So the glider was launched by 2 helpers who gripped it firmly by the wings and ran forward until it lifted off. Because of this frustrating lack of lift, the total time the Wright brothers spent in the air during the entire 1900 testing season added up to a measly 2 minutes. Obviously, that wasn't nearly enough to learn anything useful about the design or how to fly. Undeterred, in 1901, the inventors built a completely new, larger glider. Now its wing area exceeded 290 square feet, its wingspan reached 22 feet, and its weight had grown to nearly 99 pounds. They also gave the wing a deeper curve. The overall control philosophy remained unchanged, but there was one interesting new detail. Now the wing warping was no longer controlled by a simple lever. The pilot, still lying on the wing, controlled flight using a special wooden frame. He simply shifted his hips left or right, and the mechanism responded obediently to these body movements. Testing of this updated machine began at the same Kittyhawk in July 1901. This time, the brothers ditched the ropes and tested the craft exclusively in free flight. But to their huge disappointment, the results were once again far worse than they'd expected. During glides, the craft descended too steeply. The glide angle ranged from 10 to 13 degrees, even though all their mathematical calculations predicted no more than 3. A string of serious control problems showed up too. The biggest headache was the front elevator. It worked extremely poorly and sometimes had the exact opposite effect. The glider would do the opposite of what the pilot wanted. It later turned out that the overly curved wing shape was to blame. When the glider flew level with a minimal angle of attack, the pressure on the wing distributed unpredictably and shifted sharply backward, making the craft unstable and nearly impossible to control. This aerodynamic problem was solved fairly simply. the brothers slightly reduced the wing's curvature. But another mystery emerged that was extremely hard to explain. The glider responded to changes in wing angle in completely unexpected ways. In August 1901, Wilbur wrote to his friend Octave Chanute, describing their frustration. The machine absolutely refused to turn toward the lowered wing. This completely unexpected result, he said, blew apart all their theories about how turns should work in the air. In reality, the Wright brothers had just encountered for the first time what pilots today call adverse yaw. It occurs when ailerons are deflected or wings are warped. In simple terms, on the tip of the rising wing, extra drag builds up. This drag acts like an aerodynamic brake and tries to turn the aircraft the wrong way. During their persistent experiments in 1901, Wilbur and Orville Wright took turns at the controls and made several hundred test flights. Their maximum gliding distance reached 387 feet. But despite these numbers, the inventors were still a long way from a real breakthrough. Although they did everything they could to improve handling and flying qualities, their 1901 glider had no significant advantages over older models that relied solely on the pilot's body for balance. The Wright brothers designed their first truly successful glider the following year, 1902. But first, they put in months of exhausting work. They independently built a wind tunnel where they meticulously tested various wing profiles and shapes. Thanks to these experiments, they were able to make a series of important changes that improved the new craft's behavior in the air. The most important decision was to use a much longer and narrower wing, along with a change to its overall curvature. As a result, the glider's efficiency increased by roughly 50%, which was a huge breakthrough. An equally important step was improving the roll control system. When the brothers became fully convinced that controlling flight direction through wing warping alone was impossible, they decided to add a vertical tail at the rear. Initially, this was simply a fixed assembly of two parallel surfaces. However, test flights quickly showed that even this design didn't solve the problem of unwanted yaw. The raised wing, as before, created strong air resistance and fought against the turn. This only worsened the bank angle, and the glider could slip into an uncontrolled skid. During one such flight, Orville Wright actually crashed and nearly killed himself. They eventually found an elegant solution. The brothers replaced the fixed vertical tail with a movable one and mechanically linked it to the wing warping system. Now the rudder automatically turned in the direction the glider was banking. Thanks to this brilliant idea, the difference in air resistance between the right and left wings was fully compensated, and smooth, proper turns were finally possible. In March 1903, the Wright brothers officially patented this revolutionary technical solution. Now that they had a glider with a truly effective control system, they made about 1,000 flights over the course of 1902. Their total time in the air reached 4 hours. The best flight lasted 26 seconds, covering a distance of 623 feet. The very next year, they pushed that record significantly. Despite its fairly large dimensions, a wingspan of 32 feet and a wing area of 305 square feet, the glider responded reliably to the pilot even during strong gusts. Octave Chanute, who personally witnessed these tests, was deeply impressed and admitted that the Wright brothers' craft was far ahead of every other glider of the time. Now the inventors faced the next logical step, turning their successful glider into an actual airplane. At the end of 1902, the brothers shared their next big idea with Chanute. They told him they intended to build a considerably larger machine, roughly twice as heavy as their current craft. They'd use it to study the challenges of launching and controlling substantial weight. And if it responded well to the controls in flight, they would definitely install an engine. Soon after, the Wright brothers made a bold decision to build a real airplane right away, without wasting time on yet another unpowered prototype. This move fundamentally changed the inventors' approach to their work. While glider flights had been more of an exciting hobby before, and they'd happily shared their successes with the public, everything was different now. Once they started work on a powered airplane, the brothers decided to keep every detail of its design as secret as possible. They understood perfectly well, whoever built the first working powered airplane stood to win fame and fortune. It was this secrecy that kept them from discussing their work with the renowned American scientist and inventor Samuel Langley, who was also trying to build an airplane. For the same reason, they flatly turned down French glider pilot Ferdinand Ferber when he asked to visit them at Kittyhawk. The engine and propellers for the future airplane were built in Dayton during the winter and summer of 1903. The reason they built the power plant so quickly was simple. Unlike many predecessors, the Wright brothers didn't try to invent some unique or ultralight motor. They took a very practical approach. A 4-cylinder water-cooled gasoline engine was built to their specifications. It produced 12 horsepower and was, essentially, just a lighter version of a standard car engine. It weighed about 180 pounds. In terms of power-to-weight ratio, that came out to about 15 pounds per horsepower, which was actually more than the old steam engines on other designers' flying machines. But the brothers had done their math carefully and were confident this power would be enough for takeoff. As it turned out, the Wrights themselves believed that 8 horsepower would be enough to get them airborne. In reality, as history showed, that wouldn't have been enough. Luckily, the engine they ordered turned out to be more powerful than expected, and that extra power is what got the airplane off the ground. To create effective propellers, the inventors used the results of their own wind tunnel experiments conducted during the winter of 1901 to 1902. Their approach was brilliant. They treated the propeller not simply as a blade, but as a rotating wing. By carefully selecting the best aerodynamic profile for each section, they created a propeller with an impressive efficiency of 66% for that era. These propellers were connected to the engine through a special chain drive with a reduction ratio of roughly 3:1 for better efficiency. The entire system, propellers plus transmission, weighed approximately 90 pounds. The foundation for the new powered airplane was their successful 1902 glider. However, since the machine with an engine was considerably heavier, the wing dimensions had to be significantly increased. They also expanded the control surfaces. Instead of single rudders, they installed double ones, so the airplane would respond better to the pilot. Just like the older machines, the rudder automatically turned when the wing changed its angle, and for safe landings on soft sand, special skids were mounted under the lower wing. Final assembly took place in the fall of 1903. When the brothers arrived at the test site in Kittyhawk. What they'd built was a classic biplane with 2 pusher propellers that spun in opposite directions to counteract torque. The engine was mounted on the lower wing, slightly to the side of the pilot's position. The pilot didn't sit in a cockpit. During flight, he had to lie on his stomach and control the wing angle by shifting his hips side to side. In front were 2 levers. One controlled the elevator to raise or lower the nose, and the other allowed the pilot to start and stop the engine. The total takeoff weight of the machine was about 750 pounds. The wing area reached 510 square feet, the wingspan exceeded 40 feet, and the overall length of the airplane was nearly 21 feet. Each propeller was 8.5 feet in diameter. When the first ground test began, a serious problem emerged. The propeller shafts weren't strong enough and broke easily. Repairing and strengthening these parts ate up a lot of time. Meanwhile, winter crept in. Bitter cold set in, with rain and brutal winds. Despite all these difficulties, the Wright brothers firmly decided not to postpone the main test until the following year. Because their new airplane was too heavy, the inventors had to abandon the old launch method. Before, local residents would simply run alongside and help the craft take off by holding the wing edges. If they'd had that kind of help, critics could have argued the airplane didn't take off under its own power. That's why a key decision was made. The airplane had to take off completely on its own, without any outside help. To get airborne, the airplane had to accelerate along a special wooden rail, about 59 feet long. The top of the rail was covered with iron strips to reduce friction. The craft itself moved along this guide on a small dolly that detached automatically right after takeoff. To minimize the takeoff distance, the launch always had to be straight into the wind. The first full tests of the airplane, which the Wright brothers proudly named the Flyer, were scheduled for December 14th. That day the wind was too weak, so to help the machine build up speed, the launch rail was placed on a sandy hillside at a 9-degree angle. The engine fired up, the airplane rolled downhill over 52 feet, and finally left the ground. But the triumph was short-lived. Within moments, the craft pitched its nose up sharply, lost control, and fell onto its wing from a height of about 16 feet, burying itself in the soft sand. Fortunately, the damage turned out to be minor, and the pilot, Wilbur Wright, was completely unharmed. The stopwatch didn't lie. This first flight lasted only 3.5 seconds. The crash happened because the elevator was jerked too hard. They quickly figured out it had been poorly balanced. Having learned their lesson, on December 17th, the Wrights conducted a second round of tests. This time, a fairly strong wind was blowing, so the rail was placed perfectly level. Orville Wright left a very detailed account of that historic day in his journal. According to Orville, they spent a few minutes warming up the engine to make sure it was running smoothly. At 10:35 in the morning, he began the first test. Their instruments showed that the wind speed exceeded 20 miles per hour, though the official weather station at Kittyhawk was clocking 27. The moment they released the restraining cable, the machine shot forward, picking up speed until it reached somewhere around 7 or 8 miles per hour. The airplane lifted off the launch dolly right as it reached the fourth section of the rail. Their assistant, Mr. Daniels, managed to take a photograph at the exact moment of liftoff. Right away, Orville realized that controlling the front elevator was extremely difficult. Because its center of gravity was too close to the axis, it kept trying to turn on its own, swinging erratically from side to side. Because of this, the airplane first unexpectedly shot up about 10 feet, and then, after his attempt to level it with the elevator, dove just as sharply toward the ground. That ended the first flight. The machine traveled about 100 feet from the end of the launch rail. He was in the air approximately 12 seconds. They never got the exact time because nobody stopped the watch in time. The impact broke the engine control lever and cracked the wooden skid under the elevator. After a quick repair at 11:20, Wilbur made the second flight. The airplane's path was still wavy. The machine kept bobbing up and down. The distance was longer, though the time in the air was about the same. They didn't measure the exact distance, but it looked like around 175 feet. The wind had died down a bit by then. Together with the life-saving station crew who were present, they picked up the craft and carried it back to the launch rail by hand. Around 11:40, Orville began the third test. When he'd flown about the same distance as Wilbur, a powerful gust suddenly hit from the left side. It lifted the left wing, the airplane tilted sharply, and it drifted noticeably to the right. He immediately pulled the elevator to descend slightly, then engaged the wing warping system to level out. The airplane unexpectedly brushed the ground with its left wing. Orville noted that this proved their new machine's side-to-side control was much better than on all previous craft. At the moment of that sudden bank, they were at an altitude of 12 or 14 feet. Right after noon, Wilbur set off on his fourth and final flight. At first, the machine was again making sharp jumps up and down just like before. But once it passed the 300 or 400-foot mark, Wilbur felt that the airplane was handling much better and flying remarkably smoothly. This stable flight lasted until the flyer approached a small hill about 800 feet from the launch point. There, the airplane started bucking again, suddenly lost altitude, and dove toward the ground. The front elevator frame was badly damaged, but the main wing structure miraculously survived intact. Apart from the elevator, the airplane's structure was completely undamaged. The flyer covered the 852-foot distance in just 59 seconds. However, shortly after it was carried back to the starting position for the fourth time, bad luck struck. A sudden, very strong gust caught the machine and flipped it over. The wing was broken and the transmission mechanisms were seriously damaged. Due to the rapidly worsening weather, the Wright brothers decided not to repair the airplane right there and returned to their hometown of Dayton. Those trials on December 17, 1903, marked the first true powered flights in history. Of course, before them, the French inventor Ader, the Briton Maxim, and the German Giotto had attempted short hops. But in reality, those were just uncontrolled hops of about 100 feet, which almost always ended in crashes. In contrast, the flyer managed to take off successfully several times in a single day, with the pilots in full control the entire time. It was the very first heavier-than-air machine in the world capable of sustained, stable flight. This success came from a methodical approach to building an airplane. They refined their craft step by step. From a small, unmanned model, they progressed to a full-scale glider, and from the glider to a real powered airplane. They did everything themselves, designing, building, and flying. Over the next 2 years following that triumphant first flight, the Wright brothers worked in strict secrecy, away from prying eyes. They constantly upgraded their design. They put in a stronger engine, reworked the controls, and added a bigger fuel tank. To make takeoffs easier, the inventors devised a launch catapult, a tower with a heavy weight that dropped down and, through a system of cables, gave the airplane the extra boost it needed for takeoff. Thanks to these clever engineering solutions, flight duration increased noticeably. What's more, the Wright brothers now learned not only to fly in a straight line, but to execute turns high in the sky with skill and confidence. The Wright brothers offered their airplane to several governments, including the United States, Britain, and France. The United States Army eventually purchased a Wright airplane in 1908. They also approached the Russian Empire. In the spring of 1906, the brothers wrote to the War Minister. In it, they stated that after long years of complex experiments, they had finally created a heavier-than-air flying machine. It was perfect for military use, and they were offering it to governments around the world. The brothers' terms were as follows. First, they would provide a ready-made airplane without any gas balloons, capable of carrying a person at speeds over 30 miles per hour, with enough fuel to fly 100 miles. Second, they committed to training a representative of the purchasing country to operate the craft. Third, the brothers promised to share all their scientific data with government specialists for the further development of aviation. And finally, to provide formulas for building airplanes of any size and speed. Furthermore, the inventors warned that while they weren't selling exclusive rights to their patent, they were willing to temporarily suspend sales of the airplane to other nations, provided the Russian government was the first to sign a contract. The Wright brothers didn't demand payment up front, and guaranteed that they would first demonstrate their machine's capabilities live before government representatives. Right around the time this letter arrived, Russian military officials were grappling with the aftermath of their loss in the Russo-Japanese War. The military was desperately searching for new technologies and actively developing plans to use aircraft to support the Army and Navy. However, their attention wasn't focused on airplanes at all. The leadership was betting on balloons and massive airships, since every previous attempt at building an airplane had ended in spectacular failure. In the Russian Empire, hardly anyone had heard of the Wright brothers at that point, so it's no surprise their letter went completely unanswered. But everything changed in 1908. That's when the inventors unveiled their dramatically upgraded airplane, the Wright Model A. Thanks to a more powerful engine, this machine could now carry 2 people. Better yet, both the pilot and passenger now sat upright rather than lying on the wing as in previous versions. That same year, Wilbur Wright brought this airplane to France, where he was an absolute sensation, effortlessly smashing every aviation record. The new model stood out from the early European aircraft. It was faster, more maneuverable, and handled wind well, not just dead calm. Representatives of the Russian military were watching these demonstration flights very closely. What they saw impressed them so much that in 1908, the Imperial War Ministry made a strategic decision. The country urgently needed to develop its own combat aviation. Realizing it was too early to rely solely on domestic designs, the generals decided to simultaneously purchase 2 foreign machines. One of them had to be the famous Wright brothers airplane. As early as February 1909, 15,000 rubles, a very substantial sum at the time, was transferred to the French company Ariel, which had just begun manufacturing American airplanes in Europe. The French manufacturers provided clear guarantees. The ordered aircraft would carry 2 people and have enough fuel to stay airborne for a full 3 hours, traveling at approximately 34 miles per hour. But the machine would never reach its buyer. In 1909, during a routine test flight, the craft suddenly lost control, crashed to the ground, and was totally destroyed. The French pilot Lefebvre was killed on the spot. This horrific tragedy unfolded right before the eyes of a military attaché who had come to France specifically to accept the finished airplane and learn to fly it. To salvage the company's reputation, Orville Wright personally ordered the Ariel Company to urgently build and ship 2 new airplanes to St. Petersburg to replace the one that was lost. However, news of the crash had already spread worldwide, fueling doubts about the reliability of Wright aircraft. And although the War Ministry didn't officially cancel its order, the All-Russian Aero Club, which had also been planning to buy these American machines, decided to put the contract signing on hold. It might have seemed like the story of American airplanes in the Russian Empire would stall at that point, but it took a completely unexpected turn thanks to a man named Nikolai Popov. He had a remarkable life story. After training as an agronomist, Nikolai unexpectedly decided to change his life completely and went into journalism. During the Russo-Japanese War, he worked as a war correspondent in Manchuria. In one battle, he was shot through the chest, but he survived. After recovering from his serious wound, in 1907, the journalist headed abroad to start fresh. The following year, he joined the crew of the massive American airship America, which was attempting to reach the North Pole. The expedition didn't last long, though. Almost immediately after launching from the Arctic island of Spitsbergen, the airship suffered a serious malfunction. The crew's lives were saved by Norwegian sailors who happened to be nearby. After this adventure, Nikolai moved to Paris, where he caught the flying bug. Almost entirely on his own, he learned to fly a Wright brothers airplane. In the spring of 1910, during a major aviation competition in Cannes, France, Popov performed impressively, earning high marks and a special prize for record altitude. Naturally, he was invited to the first major aviation week in St. Petersburg. Besides participating in these historic air races, the pilot had another important assignment. The aerial company had tasked him with officially delivering those 2 airplanes to the military and training local officers to fly them. In April 1910, Nikolai Popov, along with 2 disassembled American machines, successfully arrived in the capital. The Grand Aviation Week was held at the city hippodrome from late April to early May. Thousands of excited spectators gathered to see something most of them had never witnessed before: airplanes in flight. In the sky above the city, alongside the American machines, well-known French airplanes were also flying: the Farman, the Voisin, the Blériot 11, and the elegant Antoinette monoplane. The performances by Popov, who at that point was the only local aviator at the event, drew considerable attention from the crowd. Eyewitnesses described their impressions of the first day of flights with incredible enthusiasm. After careful preparation, Popov's airplane accelerated rapidly along the special launch rail, and at the end of the track lifted off the ground easily and confidently. At this moment, orchestras played, and the excited audience watched in amazement. Gaining altitude, the pilot boldly flew right over the grandstands, banking turn after turn and leaving the crowd speechless. With each new lap, the aircraft climbed higher and higher, mesmerizing the audience. The pilot's skill and the Wright airplane's smooth flight drew admiration from the crowd, and with every minute in the air, the applause only grew. Nikolai Popov made 14 laps, staying airborne for 25.5 minutes. The moment he touched down, the audience erupted into a thunderous ovation. Even the senior military officials joined in. During these competitions, Nikolai Popov managed to damage both of his airplanes through poorly executed sharp turns. But this didn't stop him from making the winners list and once again taking home the top prize for maximum altitude. Immediately after this high-profile aviation event ended, Nikolai Popov headed to the Gatchina airfield. A brand new Wright had already been delivered there, purchased specifically for training future military pilots. Popov's job was simple: thoroughly test the machine in action, and then begin flight training with the cadets. The first flight of this aircraft took place on May 21st. Popov settled into the pilot's seat, took the machine up without any trouble, and circled calmly for about 15 minutes. Satisfied that all systems were working perfectly, he was already planning to come in for a landing. But then something unexpected happened. The engine suddenly went silent and stopped. The pilot had to make an emergency landing on an uneven dirt field. During the landing gear hit a sizable mound, and the craft flipped over violently. From the powerful impact, the heavy engine literally crushed the pilot underneath it. He was rushed to the nearest hospital, completely unconscious. The injuries turned out to be extremely serious: a severe concussion, a broken nasal septum, and multiple fractures in his arm and leg. Doctors managed to save his life, but Nikolai Popov was left disabled. His flying career was over for good. He later went abroad for treatment and never returned to the Russian Empire. To replace the injured instructor and continue pilot training, another experienced aviator, a Frenchman named Gobert, was specially invited from France. But by that time, the initial enthusiasm for American airplanes among the public and the military had noticeably faded. And the reason wasn't just the terrible crash. As it turned out in practice, the Wright was very poorly suited as a training airplane. It was so unstable in the air that beginners could barely handle it. A popular aviation journal in August 1910 even published this article. Today, these machines are rapidly losing their popularity. On one hand, this is due to the overly primitive design of their engines, and on the other, due to serious shortcomings in the airframe itself. The problem was that the pilot had to use both hands simultaneously to maintain control. The tail section was also designed poorly. The horizontal stabilizer had too little surface area and was positioned too close to the main wings. Because of this, the airplane had virtually no automatic stabilization. The pilot had to stay fully focused every single second, constantly leveling the machine, making flight physically and mentally exhausting. The article also added, "Only in the hands of a truly outstanding master, such as the French pilot Gober, can this machine fly relatively level. Under normal conditions, the machine wobbles through the sky like a boat bouncing across rough waves." Besides the control problems, there was another significant obstacle. The engine produced only 30 horsepower, which was nowhere near enough. Because of this low power, the airplane simply couldn't take off with a passenger or trainee on board, even though that capability was clearly specified in the original contract. All these numerous shortcomings forced the military leadership to definitively reject the very Wright that Gober had so diligently tested. Moreover, they decided not to buy any more airplanes of this model. But the story didn't end there. Besides the so-called government Wright airplanes, there was one more such machine in the empire, purchased entirely with private funds. Its new owner was Theodore Kalip, an ambitious director of a company called Motor, based in Riga. Theodore Kalip was a man of great vision, and one of the first to decide to establish his own mass production of airplanes and aviation engines. The purchased Wright was meant to serve as a reference model, on the basis of which they planned to create the first batch of locally assembled aircraft. This time, the machine was ordered from Berlin, under a contract with the Flugmaschinen and Wright Company. The long-awaited machine was successfully delivered to Riga on March 2, 1910. To fly it and demonstrate all its capabilities, a qualified pilot named Otto Arntzen was specially invited from abroad. They scheduled a grand public demonstration for May 30th. It was held at the spacious Riga Hippodrome, but the big show never happened. The demonstration was a total disaster. Out of 7 attempts, pilot Arntzen managed to get his machine airborne only once. But even that flight ended in a crash. During a turn, the strut between the wings to which the fuel tank was attached broke. Fortunately, all this happened at very low altitude, close to the ground, so the aviator was completely unharmed. A month later, Arntzen made another attempt to fly, but it also went nowhere. Despite the constant setbacks, engineer Kalip kept his enthusiasm and stuck with his ambitious idea. In one historical document, he wrote that, seeing the need for homegrown aviation engines, in 1910, his team at the Riga factory began building an aviation engine of the automotive type. Their first engine had water cooling and produced 35 horsepower. It was installed on the Wright aircraft, and thanks to this engine, they made quite a few successful flights. This engine, manufactured in Riga, was a significantly improved version of the original Wright brothers engine. Thanks to a series of technical improvements, it was able to produce a third more power than the original. The airplane itself was also fully assembled at the motor company. To simplify the piloting process as much as possible, Kalip decided to add a small horizontal stabilizer to the design. In addition to the usual wooden skids under the wings, he installed full-wheeled landing gear. On January 11, 1911, Riga pilot Max Trautmann took this improved Wright into the sky, right from the factory airfield. After flying a distance of several miles, he landed safely and softly on the outskirts of Riga. Shortly after, Kalip shifted to producing engines and airplanes of entirely different designs. This happened because after the tragic incident with aviator Popov and the enormous difficulties in training new pilots on Wrights, these airplanes quickly lost their initial popularity. The Wright brothers' flying machine was a biplane built on a canard layout. What this meant is that the stabilizer, which also consisted of 2 surfaces and doubled as the elevator, was located not at the rear, but at the front of the airplane. Meanwhile, at the tail was a double vertical rudder that rotated fully. The upper and lower wings had a very thin, curved profile, whose shape was maintained by closely spaced ribs. At the core of each wing were 2 longitudinal beams, with the front beam simultaneously serving as the wing's leading edge. The trailing edge was made with an elegant simplicity. From steel wire, firmly clamped between the tips of the ribs. The wing frame was covered with thin, unbleached cotton muslin. The tail surfaces and front stabilizers were covered with this same material, but only on one side to save weight. The pilot controlled direction and roll by warping the wings while simultaneously turning the tail rudder. The pilot controlled the craft not with a traditional control stick, but with movements of his own body, shifting a special cradle in which he lay to the right or left. The heart of the airplane was a 4-stroke engine. Its peak output was about 16 horsepower, quickly settling to a steady 12 horsepower in flight. In 1902, no machine shop was willing to build them an engine weighing a mere 180 pounds. So the brothers had to build it themselves, putting together a custom engine in their own workshop. This power was transmitted to 2 propellers that spun in opposite directions via a chain drive. The propellers themselves were carved from wood and had a thin, carefully calibrated curved profile. Finding the right shape and size took countless experiments. This airplane didn't have the wheeled landing gear we're used to today. To get it airborne, the designers built a special launch catapult. It consisted of a tall pyramidal tower and a long wooden guide rail. The launch mechanism worked by means of a heavy weight that dropped from the tower and pulled a cable. This cable, running through a system of pulleys, was attached to the airplane and gave it the initial acceleration needed for takeoff. Thanks so much for watching. If you enjoyed this video and learned something new about the incredible story of the Wright brothers, please give it a thumbs up. It really helps the channel grow. Don't forget to subscribe and hit that bell icon so you never miss a new video. And I'd love to hear from you. Drop a comment below and let me know. What surprised you most about the Wright brothers' journey? See you in the next one.